Hello everyone, my name is Net Saroj.
And today, I will explain Assignment 1 from Data Communication and Networking in a clear, step-by-step way. In the frames per second, multiplying pixels per frame by bits per pixel, and then by frames per second, the data rate comes out to nearly 11.94 gigabits per second, showing that transmitting ultra-high-definition video requires optical fiber with huge bandwidth. In the second problem, we are asked about a 6 MHz television channel using 4-level signaling. By applying the Nyquist theorem, capacity equals 2 times bandwidth times log base 2 of signal levels, which results in 24 megabits per second, demonstrating how more levels increase channel efficiency. In the third problem, a 3 kHz channel with a signal-to-noise ratio of 20 decibels is analyzed. Converting dB to its linear value and using Shannon's theorem, the maximum rate is about 20 kilobits per second, much higher than the 6 kilobits per second possible with only binary signaling. The fourth problem deals with frequency division multiplexing, where 10 signals each of 4,000 Hz are combined with 400 Hz guard bands. The total bandwidth needed is 43.6 kHz, where guard bands act like safety gaps, preventing interference. In the fifth problem, we explain why PCM sampling time is set at 125 microseconds. Since telephone signals have a maximum frequency of 4 kHz, Nyquist requires at least 8,000 samples per second, and the reciprocal gives 125 microseconds per sample. The sixth problem asks what SNR is required to transmit a T1 carrier of 1.544 megabits per second over a 1 megahertz line. Using Shannon's capacity formula, the result is about 2.8 decibels, which is quite small but realistic with efficient encoding. The seventh problem asks whether a cable TV system with 100 channels is more like TDM or FDM, and the answer is clearly frequency division multiplexing, since each channel is allocated a different frequency band, and all transmit simultaneously. Finally, the eighth problem looks at providing internet access over cable to 5,000 houses, where each must get at least 2 megabits per second. Multiplying gives 10,000 megabits per second total, and since each cable provides 100 megabits per second, the company needs 100 cables, with each serving 50 houses to meet the guarantee. These 8 problems illustrate how data communication relies on principles of bandwidth, multiplexing, signal-to-noise ratio, and sampling. We connected the formulas with real-world examples like Netflix streaming, telephone PCM systems, cable TV broadcasting, and broadband internet. That completes Assignment 1, and I hope the explanations made every step clear. Thank you for attending this lecture with me. I am P. Hari. See you in the next class.